Lesson 7.4 is using special right triangles to solve problems. First special right triangle we're going to look at is an isosceles right triangle. What I've done is taken a square, cut the diagonal through it. That gave me a 90-degree angle with two sides equal to each other. By our base angle theorem, we know that these angles then are congruent, and if they are, that makes them 45 degrees. So we can easily show that that's a 45, 45, 90 triangle. We can use Pythagorean theorem then to find the length of the hypotenuse. The hypotenuse is the square root of the sum of the squares of the legs. So I get the hypotenuse is the square root of 2x squared. We know the square root of x squared is x, so we can take that out and have h, or the hypotenuse, is equal to x times the square root of 2. Theorem 7.8 we just showed is that if you have a 45, 45, 90, the hypotenuse is always going to be the square root of 2 times as long as whatever the legs are. So in this case, when you've got x, then the hypotenuse is x times the square root of 2. How can we plug that in? Well, if I have a 90-degree angle and a 45-degree angle, that automatically makes the third angle 45 degrees. And so this side is 10, so I've got a 45, 45, 90 triangle. And so the hypotenuse is equal to the leg times the square root of 2. So in this case, that's 10 times the square root of 2. If I have that each of these sides are 5 square roots of 2, that means that each of these angles are 45 degrees because the base angles of an isosceles triangle are equal, and therefore my hypotenuse is the leg times the square root of 2. Well, in this case, the leg is 5 square roots of 2. Multiplied times another square root of 2 gives me 5 times 2, or 10. Find the lengths of the legs of this triangle. Well, since it is an isosceles triangle, since both of these are x, then what I have is hypotenuse is equal to the leg times the square root of 2. So 5 times the square root of 2 is equal to x times the square root of 2. Well, using logic, that would mean that x would have to be 5, or you can simply work it out algebraically by dividing each side by the square root of 2 and getting that x is 5. Standardized test problem you may see, what I have is a 90-degree and a 45-degree, so the other one is a 45-degree angle. That means this is an isosceles right triangle, and so my hypotenuse, which is wx, which is what I'm looking for, is the side times the square root of 2, or the leg times the square root of 2, so 25 square roots of 2 is b. So here's your guided practice. Give it a try and then check to see if you got it right. What I have is the hypotenuse is equal to the leg times the square root of 2. So my hypotenuse is 2 square roots of 2 is equal to x times the square root of 2. So in this case, x is 2. In this problem, once again, hypotenuse is equal to the leg times the square root of 2. In this case, hypotenuse is y. That's the square root of 2 is the leg times the square root of 2. So in this case, y is 2. And here I have a square that has been cut with a diagonal. That diagonal becomes the hypotenuse of an isosceles right triangle. Therefore, it is the leg times the square root of 2. So 8 square roots of 2. Find the leg length if I have a right isosceles triangle with a hypotenuse of 6. So once again, we have that 6 is equal to the leg times square root of 2. So if I want to solve that, I have 6 divided by the square root of 2 is equal to x. If you remember, we need to rationalize that denominator, 6 over the square root of 2 multiplied times the square root of 2 over the square root of 2, which gives me 6 square roots of 2 over 2, which is where the 3 square roots of 2 comes from. Another special right triangle is formed by taking an equilateral triangle. Now, you know, in an equilateral triangle, all angles, all sides are equal. So that means that the angles of an equilateral triangle are 60 degrees. So I have 60 degrees, 60 degrees. This divides this angle into 30 degrees because the altitude and the angle bisector and the median are all the same line in a equilateral triangle. Notice I made these longer sides 2x so that when I divided this one it just became x. If I use my Pythagorean theorem, h is a leg of this right triangle. So remember, using Pythagorean theorem for my leg, I'm going to have that h is equal to the square root of the hypotenuse squared, so quantity 2x squared, minus the leg squared, so minus x squared. So I have 4x squared minus x squared is 3x squared. Once again, square root of x squared is x, so the hypotenuse is x times the square root of 3. That takes us to our next theorem. In a 30, 60, 90 triangle, the hypotenuse is exactly twice as long as the shorter leg, because if I took that 2x and divided it in half, I get x, so x and 2x, and then the longer leg is x times the square root of 3. The logo on a recycling bin resembles an equilateral triangle with side lengths of 10 centimeters. What's the approximate height of the logo? So I'm going to draw the equilateral triangle described. Its altitude forms the longer leg of two 30, 60, 90 triangles. The length h of the altitude is approximately the height of the logo. So when I divided this, it became 5. And so my longer leg is the shorter leg times the square root of 3. So in this case, that is 5 square roots of 3, or approximately 8.7 centimeters. Find the values of both x and y. Well, we can see that I have a 30, 60, 90 triangle. We know that the longer leg, which we know is 12, is the shorter leg times the square root of 3. So 12 is x times the square root of 3. I'm going to need to simplify that and rationalize the denominator, and what I end up with is 4 times the square root of 3 for x. Now the hypotenuse then is twice as long as that, so 2 times 4 square roots of 3 gives me 8 square roots 3 for the hypotenuse. This says the body of a dump truck is raised to empty a load of sand. How high is the 14-foot body from the frame when it's tipped upward at the given angle? So we're raising this. This line here is 14 feet. We're going to be measuring this angle here. And we have a right triangle because the tip here is measuring down to the base is a right angle. So if it's a 45-degree angle, what we've got is a 45-degree angle here with 14-foot bed. My hypotenuse is the leg times square root of 2, and that 14 feet is the hypotenuse. So I can reduce that down to approximately 9.9 feet. What about if it's raised to a 60-degree angle, like this one? Well, what I know is that then this is the short side down here. And this is the long side. So what I'm looking for is the long side, which is 2 times the short leg. The hypotenuse is 2 times short leg. 14 is 2 times s, so s is 7. And then the long leg is that 7 times the square root of 3. So guided practice, here it is for you to find the variable. Remember, on a 30, 60, 90 triangle, the long leg, which is what I'm looking for, the long leg is equal to the short leg times square root of 3. So in this case, the long leg is equal to the short leg times square root of 3, so x is 3. What about in this one, finding h? Well, this is my short leg is 2, and h is my long leg, so the long leg is the short leg times the square root of 3. 2 times square root of 3. What if in example 14, what is the height of the body of the dump truck if it's raised 30 degrees above the frame? Now let's remember what that looked like. We had a 14-foot bed, and if this is 30 degrees, we're looking for the short side. So the short leg, the hypotenuse, is equal to the short leg times 2. So 14 feet is equal to 2x, so x is 7 feet. In the 30, 60, 90 triangle, describe the location of the shorter leg, describe the location of the longer side. Well, that shorter side is always across from the smallest angle, so the short side is across from 30-degree angle, and the long side is across from the 60